Hey, welcome everyone. Trying something new. Trying to do a noon live stream. Might as well take advantage of the lunch hour and get out and talk a little bit more about coatings, corrosion, and other topics as well. So I appreciate you joining me today here on Monday. Last week was MEGARUST in San Diego. I had the opportunity to not only attend but also to participate. I did a presentation which I want to share with you because I had a lot of people after I posted about delivering this presentation. A lot of people asked for a copy of it, but also a lot of people had asked if I would share it and broadcast it. So I figured, why not do that? It's a great opportunity to share some information that I wanted to make sure that I delivered to the attendees and participants at MEGARUST last week. There were a lot of great contacts from Navy, from contractors, industry professionals, both on the protective coating side and corrosion side, and importantly, a lot of shipyard connections. And it was a great opportunity. Very good topics covered. I highly recommend that if you are in protective coatings and corrosion and you are doing things that, let's say, with the Navy, you definitely need to be participating with MEGARUST. So with that being said, I wanted to go ahead and talk about how spray painting drones, how these systems are really emerging as a transformative force multiplier, especially for the Navy shipyards. These shipyards are tasked with maintaining fleet readiness and increasingly under faster timelines. Also, when it comes to quality assurance and quality control, a lot more strict requirements. And as vessels are going into the future, we're starting to see very complex vessel geometries that are coming to play. So the presentation I delivered, it examined really how autonomous and semi-autonomous aerial spray platforms will enhance the coating productivity, focus heavily on the safety aspect and risk mitigation, but also the consistency, especially across large-scale marine assets. What I wanted to try to provide to the attendees of the presentation was that have them kind of understand the operational advantages that drone-applied protective coatings, especially in the reduction of the reliance on scaffolding and lifts and all the time it takes and labor and cost to basically stage production, and how drones can really apply protective coatings but minimize that amount of need on lifts and scaffolding as well. Importantly, improving worker safety. And I wanted to look at aspects or present aspects of how drones can be integrated within the existing shipyard workflows. Projects don't have to be redesigned. It's a great opportunity for projects to be able to look at timeline a lot differently, and I think that was important as well. So there's a lot of efficiencies to gain from the use of drone systems and stuff like that. So the title of it, Force Multiplier, Advancing Navy Shipyard Coating Operations Through Spray Painting Drone Technology. So let's get into the presentation. So currently the Navy Shipyard Challenges, it deals around shipyard operations, because as we move into the future, we're really not going to be dealing with the same vessels or exactly the same conditions that we faced, let's say, a decade ago. Ship designs are becoming more complex with tighter geometries, deeper recesses, and larger surfaces, and those areas push traditional coating methods really to their limits. At the same time, the maintenance windows are shrinking. So the fleet needs to turn faster, and every hour that a ship sits idle, it puts pressure on schedules, budgets, and operational readiness. Now you have to layer onto everything a high expectation when it comes to quality control and quality assurance, especially under NAVSEA standards. Coating performance isn't just a quality issue, it's a mission readiness issue. There has to be consistency a lot of documentation is required, and this all has to be repeated, and everything, there's no areas that could be negotiated out. And of course, we're all feeling the impact in the industry of the persistent labor shortages and rising safety requirements. So we're asking fewer people to do more work in more hazardous environments with less margin for error. And it just all leads to a simple truth that the Navy needs predictable, repeatable coating performance at a scale and speed that traditional methods alone cannot readily deliver. And that's the challenge. And that's exactly where spray painting drone technology becomes a force multiplier. So let's talk about why force multiplier matters. When we use the term force multiplier, we're talking about technology that strengthens the capability of the skilled workforce, not technology that replaces them. Spray painting drones fit squarely into this definition. They augment applicators, it gives them the reach, it gives them the consistency, and also provides the efficiency that simply are not always achievable with manual methods alone. Now, this matters because shipyards don't have the luxury of unlimited manpower. With persistent labor shortages, the only way to increase throughput is to expand production capability and capacity without expanding headcount. So a force multiplier gives every painter more impact per shift. It also removes some of the biggest bottlenecks in the shipyard. Talked about it earlier, scaffolding, lifts, and access constraints, which really slow down coating operations more than any other factor. When you incorporate drone technology, they can handle large vertical surfaces and hard-to-reach geometries. Crews can stay productive instead of waiting on access. And ultimately, this is about fleet readiness by accelerating coating cycles while maintaining NAVC level quality. Force multiplying technologies help ships return to service faster, safer, and more predictable from coating with coating performance. And that's why force multiplier, it's not a buzzword. It's a requirement, really, for the modern Navy shipyard. Let's talk about what spray painting drones, what they actually do. When we talk about spray painting drones, we're not talking about the consumer gadgets or the experimental things that you do find out there with drones. We're talking about industrial, purpose-built application tools. They're highly engineered around the fundamental of every coating applicator already understands. And these systems can operate in autonomous, and mostly it makes more sense to do semi-autonomous modes. This allows the operator to have some aspect of control for the work while the drone handles all of the precision. What this really means is that the drone handles the standoff distance, travel speed. They're all going to be digitally controlled and monitored in real time, fast adjustments. So it's not going to be left to a human fatigue in their application process. In other words, their technique or their body position or access limitations. Maybe they're stretching to get an area coated, or they're in not an ideal position. Because of that control, you can get consistent overlap and uniform spray pattern across large surfaces. And this is the kind of repeatability that directly supports NAVC quality control and quality assurance expectations. So the drone follows a defined flight path as it works, and it captures coating-related data, position, coverage, and performance indicators. And this is all connected to standard industry paint pumps and other equipment to do paint production. And this gives shipyards a level of documentation, especially from the data from the drone, that traditional methods can't simply match. And importantly, these platforms are designed for larger open haul surfaces and verticals. And these are the areas that can slow down crews. And it can require the most amount of access equipment to be staged. It can also carry the highest risk when it comes to safety burden. So in short, drone technology is not a replacement for the skill applicator. It's a precision tool that brings digital consistency to some of the most demanding surfaces in a shipyard. So we have to think about it. We are looking at another tool, another piece of equipment for skilled trades. So where do drones fit into Navy shipyards? When we talk about integrating spray painting drones into Navy shipyards, it's important that we're clear where they deliver the most value. These systems excel on hull sides, superstructures, and freeboard zones. The large vertical high exposure surfaces that really, as I said earlier, traditionally consume most of the time when it comes to staging access equipment and also for manpower. But they're ideal for high risk or hard to reach areas where putting a painter on a lift or staging, it really introduces an unnecessary safety exposure. So by letting the drone take the first pass, we reduce risk, keeping skilled applicators focused on the work that truly requires their expertise. And operationally, drones fit seamlessly into both pier side and dry dock environments, whether the vessel is afloat or it's blocked up. The drone provides consistent coverage without the delays tied to repositioning heavy equipment and staging access as well. They're equally effective for touch-ups and also for emergency repairs, where speed matters and access is often the bigger barrier. Instead of mobilizing scaffolding for a small correction or repair, a drone can be deployed quickly and safely. And across all of these scenarios, the common thread is this: drones remove the bottlenecks created by scaffolding, lifts, and access constraints. And this allows shipyards to maintain momentum and keep the coating operations on schedule. So this is why drones fit in. It's not going to be everywhere, but exactly where they make the biggest operational impact. So let's talk about safety as a primary driver. When we talk about spray painting drones, the conversation always starts with safety, because in Navy shipyards, safety isn't a metric, it's a mandate. And the most immediate impact on this technology is simple. It removes workers from at-height exposure. Anytime we can get a painter off a lift or get them down from scaffolding or out of a harness, we are reducing risk, and especially high-risk activities in shipyards. Now, drones reduce the need for lifts, scaffolding, rope access, which not only lowers exposure but eliminates the delays and hazards that are tied to mobilizing and repositioning all that equipment. So there's a major benefit in day-to-day working conditions. By taking on large vertical surfaces, drones minimize overspray exposure, and they also reduce operator or applicator fatigue. And this allows crews to stay fresher, safer, and more effective throughout the shift. Now, all of this supports OSHA and Navy safety objectives, engineering out the hazards and the risk instead of trying to manage them with more PPE, more procedures, and more administrative controls. And as a result of this, it's very straightforward. You got safer access, means fewer delays and fewer incidents. So when we reduce risk, we increase reliability. Safety becomes a productivity driver, not a constraint. And that's why safety isn't just what is a benefit of drone technology. It's a primary driver behind its adoption. Let's talk about productivity gains. When we look at the productivity inside Navy shipyards, the biggest opportunities aren't in precision work. They're in large, uninterrupted surfaces that consume enormous time and manpower. Spray painting drones excel here. They deliver faster coverage than manual methods can sustain over an entire shift. And one of the biggest advantages is the reduction in repositioning time. When lifts and scaffolding crews spend a significant portion of their day by moving equipment instead of applying coatings. A drone eliminates most of that. It stays in motion, it stays on the surface, and it keeps production moving. Because the system maintains continuous, consistent spray passes, you get a more predictable coverage rate and fewer slowdowns that are tied to human fatigue or access limitations. And this makes drones ideal for repetitive, labor-intensive tasks, the kind of work that drains manpower but doesn't require high precision and hand application. And the real win is that this frees up, really, by taking on heavy, repetitive surfaces. Drones allow the skilled painters to focus on the precision work, the edges, the tighter geometries, the complex components, where their expertise delivers the most value. And this is how productivity scales, not by working harder, but by deploying the right tools to the right task. Let's talk about coating, quality, and consistency. When we look at coating performance in Navy shipyards, quality and consistency are the two metrics that determine whether a system will meet NAVSEA expectations. Spray painting drones directly support both. First, they deliver uniform film build across long runs, something that's extremely difficult to maintain manually with humans on large vertical surfaces, especially late in a shift or on tight production windows. With drones, standoff distance, travel speed, and overlap are controlled digitally. And that means automated overlap and spray speed aren't dependent on operator fatigue, the body angle, or access limitations. The system repeats the same pass the same way every time. And this reduces one of the biggest variables in coating operations. That's human variability, not skill variability, but the best applicators cannot maintain perfect consistency over hundreds of square feet, but a drone can. You can also get better control in windy or variable conditions where manual spray patterns can drift and thin out. The drone maintains its path and compensates with stable, predictable application. In fact, with drones, if a human, due to wind, is not able to paint, a drone will not be able to paint. It keeps consistency when it comes to conditions. Now, all this directly supports NAVSEA coating performance and its requirements. And this gives shipyards a tool that enhances the quality, that improves the repeatability in coating operations, and also strengthens the quality control and quality assurance. So this is where drones don't just speed up production, they really elevate the standard. When it comes to material optimization, one of the most overlooked advantages of spray painting drones is how effectively they optimize material usage, a major cost driver in Navy coating operations. Because drones maintain a controlled standoff distance and consistent travel speed, they naturally lower overspray and less waste compared to human manual application on large vertical surfaces. Now that precision translates directly into higher transfer efficiency. More of the coating lands on the steel and less drifts away, and the overall film build is more predictable across the entire surface. And with this level of consistency, shipyards gain something really incredibly valuable, and that's predictable consumption rates. Instead of estimating based on variable manual production, planners can forecast material needs with far greater accuracy. And when you're dealing with high value coatings, specialized primers and anti-corrosive systems, or even NAVSEA approved top coats, that predictability becomes real money. Better control, less waste, more efficient use of every gallon. It's good for the taxpayer. Material optimization isn't just a side benefit of drone technology. It's a direct contributor to cost control and operational efficiency across the shipyard. Now, let's talk about the integration into workflows, especially existing workflows. As I said earlier, you don't have to reinvent anything when it comes to project plans or workflows. So one of the biggest questions that was posed from shipyards is that drones are considered a disruptive technology. Not really, but the question is, how disruptive is this technology? And the answer is, it's not at all. Spray painting drones are designed to work alongside traditional crews, augmenting the skilled labor. It's not going to replace them. They really do slot directly into the same coding teams, the same production plans, and the same quality control, quality assurance expectations that are already in place. One of the biggest questions is related to how do they work within the natural flow. So you have standard surface prep, you spray, and inspection cycle. There's nothing about that workflow when you have application drones in there that changes. The only difference is that a drone takes on the larger repetitive surfaces while the painters can focus more on precision work. Now, because of that, the technology introduces minimal disruption to shipyard operations. So there's no need to redesign processes, reorganize crews, or rethink the entire coating plant. The drone becomes another tool. It's a piece of equipment. It's a very highly efficient one, and that applicator team can utilize that in their toolbox. Now, operationally, these systems can deploy, like I said earlier, pier side, dry dock. It can also be afloat. And this gives shipyards, gives the Navy a lot of flexibility across multiple environments and also vessel conditions. And importantly, drones really complement, not replace, current equipment. Lift, scaffolding, and staging will still have their place in certain areas, and the drone can simply reduce how often you need to pull out lifts and scaffolding, set it up, and how long they might be required. So this is why this integration is so straightforward. The technology enhances the workflow that you already have. Now let's talk about data-driven performance validation. One of the most powerful advantages of spray painting drones is to shift from subjective evaluation to data-driven performance. Instead of relying solely on visual checks or manual notes, the system provides digital logs, spray paths, and coverage. So this can give quality control, quality assurance teams a clear, traceable record of exactly what was applied, where, and how. Now, this creates a repeatable, audible application of data. Now, that's something that does align perfectly with NAVSEA's increasing emphasis on documentation, traceability, and process control. Every pass, every overlap, every movement is captured and stored. Now, this can all be done locally, so there's no potential for capturing from outside parties the data. So, but it doesn't really stop there. With consistent digital records, shipyards can drive continuous improvement. They can analyze patterns, identify where bottlenecks are in the process, and because of that, they can redefine the process over time. So all this really does align with the Navy digital transformation initiatives. The fleet is really moving to smarter, data-enabled maintenance, and drone-captured coding data will fit clearly and squarely into that future. So this is where drones become more than a tool. They become a source of operational intelligence. Now, when it comes to touch-up and emergency repairs, in Navy shipyards, not every coating challenge is a full-scale operation. A lot of the real pressures come from touch-ups and emergency repairs. The small, unexpected issues that can derail a schedule if they're not handled quickly. Now, spray painting drones excel here because they offer rapid deployment for small area fixes without the need to mobilize an entire crew or set up heavy access equipment. And they're especially valuable for weather-impacted or schedule-critical repairs, where every hour counts. Instead of waiting for a lift for scaffolding to be assembled or a rope access team to become available, a drone can be in the air and applying coating within minutes. This capability reduces downtime and tied across constraints. One of the biggest hidden delays in shipyard coating operations was when a drone can reach that area immediately, will work and keep moving instead of stalling. And ultimately, that supports the Navy's top priority of keeping vessels on schedule for return back to service. Touch-ups and emergency repairs may be small in size, but they carry big consequences. Drones give shipyards a fast, safe, and reliable way to stay ahead of those disruptions. And this is where agility becomes readiness. Hard to access areas. When we look where spray painting drones create some of the biggest wins, it's in those hard to access areas, the places that slow crews down, that increases risk and safety exposure, and they require the most staging and equipment movement. Think about on the ship, you have overhead geometries, where painters are often working in uncomfortable positions. They're fighting gravity or relying on lifts of scaffolding just to get close enough. And a drone will eliminate that burden entirely. And the same applies really for those vertical freeboard areas where long, tall structures and surfaces demand consistent, constant repositioning of lifts. A drone can cover these areas in continuous passes without stopping dramatically, and this increases the speed and consistency. Then you have complex curvature zones. You have transition, rounded structures, and irregular geometries where maintaining standoff distance manually is difficult. The drone's automated controls help keep the spray pattern uniform, even on challenging shapes. And across these environments, the common challenge is limited equipment maneuverability. When lifts can't reach or scaffolding takes too long to erect, production stalls, and a drone bypasses these constraints. So the result is straightforward. Reduce risk, increase speed, and by taking on the hardest to reach areas, drones keep crews safer and keep the coating operations moving. Let's look at real-world usability. One of the most important points to understand about spray painting drones is this. The technology isn't theoretical anymore. We're well past prototypes and pilot concepts. These systems have proven performance in industrial environments where anything from dust, wind, humidity, and real-world constraints test every piece of equipment. They've also demonstrated reliability in marine conditions, which is critical for Navy shipyards. Salt, air, variable weather, and large steel structures can be tough on tools, but these drones are engineered to operate in exactly those environments. Just as important, they're technician-friendly. The controls are intuitive, the workflows are familiar, and the learning curve is short. Most crews achieve rapid training and adoption because the drone isn't replacing their craft, it's extending it. And all this is possible because the systems are designed for shipyard durability. They're built to handle bumps, the grit, the long shifts, and the operational tempo that define Navy maintenance cycles. Let's talk about quantifiable efficiency gains. When we talk about efficiency in Navy shipyards, it's not enough to say technology helps or improves operation. We need quantifiable gains. Spray painting drones deliver exactly that. First, they reduce labor hours on repetitive tasks. Large open surfaces that normally consume entire shifts can be completed faster and with fewer personnel. And this frees up crews for higher skilled work. They also drive down equipment rental cost. When drones take on verticals and freeboard zones, shipyards can rely less on lifts, scaffolding, and staging. some of the most expensive and time-consuming assets on any coating project. And this leads directly into faster coating cycles with fewer access delays and continuous spray passes. Production moves at a pace that manual methods can't simply sustain over long durations. And you also see fewer rework events because the drone's controlled standoff distance, overlap, and travel speed. They produce a more consistent film build. It reduces holidays, thin spots, and corrective work. And all this contributes to one of the most valuable outcomes in Navy maintenance, and that's improved schedule predictability. When coating operations become more consistent and less dependent on access equipment, the entire maintenance timeline becomes more reliable. Let's talk about cost reduction pathways. When we talk about cost reduction in Navy shipyards, it's important to understand that savings doesn't come from just cutting corners. They really come from eliminating inefficiencies. Spray painting drones really open multiple cost reduction pathways that really directly impact project budgets and overall maintenance speed and spend. First, they reduce reliance on scaffolding and lifts, which are some of the most expensive and time-consuming assets on a coating job. Every hour a drone replaces a lift is an hour of rental cost avoided. They also lower PPE and safety overhead. When fewer workers are operating at height, shipyards spend less on specialized gear, fewer spotters, and fewer administrative controls tied to high-risk work. And material savings is another major factor. When controlled standoff distance and consistent spray patterns, drones produce less overspray and reduce waste, which is especially valuable when applying high-cost NAVSEA-approved coating systems. And all this really contributes to shorter project durations because access delays, they shrink and production moves continuously ahead instead of start and stop. And ultimately, these efficiencies translate into higher throughput per crew. And the same number of painters complete more work, more consistently, and also with fewer bottlenecks. And fleet readiness impact. So at the end of the day, every improvement we make in coating operations has one ultimate purpose. That's fleet readiness. Spray painting drones directly support that mission by enabling faster maintenance turnaround. When large surfaces can be coated more quickly and with fewer access delays, vessels move through the yard and back to the fleet sooner. They also deliver more predictable coating performance, which reduces the risk of failures, rework, and unexpected delays. Predictability is a readiness asset. It keeps schedules stable and also resources aligned. This becomes especially important for critical vessels, where even minor schedule slips can ripple across deployment plans. By reducing access bottlenecks and improving consistency, drones can help lower schedule risk and also keep high priority assets on track. And all this contributes to the global deployment readiness. When ships return to service faster with more reliable coating performance, the Navy maintains the flexibility and responsiveness that's required for worldwide operations. Ultimately, spray painting drones enhance the sustainment of mission-ready assets. They also strengthen the maintenance pipeline, reduce downtime, and also support the operational tempo of the modern fleet demands. This is where technology directly translates into readiness. So what are the future of drone applied coatings? As powerful as spray painting drones are today, they are very transformative. And really, there's still a lot more ahead of us when it comes to that transformation. So we're moving it towards a future where these systems integrate directly with digital twins, and this allows shipyards to map, plan, and validate coating work against a live, data-rich model of a vessel. This means smarter planning, fewer surprises, and tighter alignment with engineering intent. We're also going to see AI-assisted spray optimization, where the system adjusts standoff distance, overlap, and travel speed in real time based on geometry, environmental conditions, and coating requirements. And this takes efficiency and consistency to a new level, one that manual methods can't simply match. And pairing drones with automated inspection technologies is another major step. Imagine a workflow where the drone applies the coating and an autonomous inspection tool verifies film build, coverage, defects, etc. And it's going to be all digitally logged and tied into the vessel's maintenance record. So as technology matures, we'll see expanded Navy use cases beyond the hull sides and the freeboard, from tanks and voids to topside structures and emergent repairs across the fleet. And ultimately, all this leads toward the long-term vision of fully autonomous coating cells. Integrated systems that prep, spray, and inspect and document entire zones with a minimal of human intervention. They're predictable, they're repeatable, and they're data-driven. So the future isn't about replacing people. It's about giving the shipyards the tools to meet the demands of the modern fleet. So here are some of the takeaways. Drones are a force multiplier, not a workforce replacement. They augment the worker, they do not replace the worker. There's huge gains when it comes to safety, also productivity, and also coating production consistency. Their drones, spray painting drones, are in strong alignment with Navy readiness and modernization initiatives, and drones are practical. They are being used, and they're very deployable today. And with that, I want to say thank you so much. I wanted to go ahead and get this information to everyone. Like I said, I had a lot of people ask if I could present this, and it was a great opportunity to share it not only at MEGARUST last week in San Diego, but also too here on this live stream. So thank you so much for joining me this lunchtime, and I will look to be doing more readily broadcast, take advantage of lunchtime as a good time to talk with everyone and also get everyone to participate in communication with the Coatings Talk community. So thank you, everybody. Have a good rest of your day and a great week.